Welcome to Breadboarding. In the previous video, the first video in the series for the 386 breadboard PC, I covered some of the schematic diagrams covering the original IBM PC from 1981, the XT from 83, the AT from 1984, the COMPAQ DeskPro, the first 386 computer from 1986, and a few other bits and pieces from the first IBM PS2 range around 1987. Now, if you've missed that video, then you may want to go back and have a look at some parts of it because I will be skipping over some bits that I covered in that video. There will be a link at the top of the screen up here and also in the description below the video. If I just show you some of the features that you may not be aware of, when you're running the videos, you can actually see chapter information at the bottom here. And if you click there, you'll be able to jump to various sections of the video. So for example, if you were going through the first video and you weren't too interested in the schematic reviews, then basically around 16 minutes into the video, if you want to, you could jump to this bit at the end and you can skip all of the schematic review bits. Also, if you look at the description below, you'll see that there's links to a lot of the things I cover actually in the video. So if it's the technical guides, websites, there's also links to the overall Breadboarding Labs channel, the project GitHub, where I'll be putting a lot of the files the 386 project up here on GitHub. Probably not for a couple of weeks yet, but I will, as soon as I've actually got things at a reasonable state, I will put them up there. And there's obviously links for all the playlists for the earlier series. And again, you can see where the chapters are. You might also find if you're not using subtitles, I do spend quite a bit of time making sure the subtitles are accurate. And sometimes when there's mistakes, when I was actually speaking in the video, I may very well correct those mistakes in the subtitles. So I recommend enabling the subtitles, and you might also find that on the longer videos, you might find increasing the playback speed to 1.25 or 1.5 times might make things go a bit quicker. You can then go back to normal speed, or I've even heard some people actually slow it down when I'm talking too fast, so apologies for that. Thanks very much for all those who've watched the first in the series. There's been a lot more comments than usual, about 43 comments so far, so thanks very much. I do try and respond to the comments within about 24 hours when I'm able to, so please feel free to ask questions, make comments. I will try and get back to you. Just a word of warning, if you reply to a reply, it's not that easy to see when there's a lot of comments where you have replied to one of my replies, so it may take a little longer to get back to you on that one. So this is video number 2 in the Breadboard PC 386. And in this video, I'm going to be looking at the COMPAQ DeskPro 386-16 design. So as I covered in the previous video, COMPAQ DeskPro 386 was the first 32-bit Intel PC. It was announced on the 9th of September 1986. It'd be nice to celebrate the 40th anniversary by having a working PC by then. DeskPro extended the PC XT and AT and was backwardly compatible with those. And in fact, the DeskPro 386 had better compatibility than the IBM PS2 range when it came out. And the DeskPro 386 really helped to define the PC standard that we're using still to this day. We'll be looking at the COMPAQ Technical Reference Guide quite a bit, and I'm going to be using an Intel 8386 DX33. So this was a slightly later chip. It's capable of going about twice the speed as the original 16 MHz chip. And when we look at these chips, invariably, although it's called 16, the actual clock frequency needed to drive it was actually 32 MHz. And for this one, it's 66 MHz to run it at 33 MHz here. And hopefully by the end of the series, what we're going to be able to do is to run Windows 3.1, Windows 95, and even an early Linux Slackware distribution. So detailed schematics are available on these links. All these links will be in the description below the video. So if you want to have a look for yourself, then feel free to go off and have a look. This one in particular is the key one I highlighted in the previous video. This is an internal COMPAQ design document or assembly of internal COMPAQ design documents, and is absolute goldmine of stuff. And it also includes the PAL-ASM programmable logic device definitions, which are very difficult to come by any other way. Now, the only drawback really of this is that the 386 DX33 aim an 132-pin socket, which is going to need a breadboard adapter, and in the next video I'm going to be looking at building that breadboard adapter. Quite often people ask me, why aren't you going to build a PCB version? Now, to be honest, the last PCB I made was back in the early 80s. It's not really my area of expertise. There is a link here to a PCB design for a 386 board, which I have had a quick look at. And I'll again include the URL in the description below. And if you really want to do a PCB version of a 386, it uses one of these very large-scale integration chips to do most of the glue logic. Not really appropriate for using on breadboards and not really that easy to understand how things work. But if you want to follow that link and you want to make one of these, then in fact, the latest rev of the board, I think by the time it gets to Rev D or Rev E, then I think it was actually functioning. So if you want a PCB version of this to play around with, then I'd suggest you go here. I'm not going to be making PCBs during this series. Now we're going to take a look at the original DeskPro 38616 and we'll compare it with a couple of different versions, in particular the version from December in 1986 for which this internal COMPAQ design document references, and there are some minor changes between the first version in September and this December version. So this diagram comes from the original DeskPro 16 September documentation. It just shows the layout of the chips on the board. And the reason for this is I'm going to show you some photographs of two versions of the DeskPro board, and you'll be able to see where the differences are, and that if you are looking at the schematic diagrams in the original technical guide, then there are differences between that and the ones we're going to be working from. So this is an image of the DeskPro 386 from the very first version of the board, and you can see down here we've got a 32 megahertz clock down here. This is the 386 processor. This, I think, is the maths co-processor. I think that was a keyboard controller up here and various other chips around here. And one of the key things here, you can actually see here if we just highlight it and zoom in. So this is actually the board reference. So this is, I think, their product code. This is 403, and the diagram referring to this is 402. And I'll show you why that's important when we come to the next one. So this is the board from December 86. So Rev D, I think it was known internally. And you can see here that in addition to the 386 processor, there is a slot for the original 287 maths co-processor, but there's also now a slot for the 387 maths co-processor. And some of the other layouts and things have changed a little bit. So you'll see the crystals and things have moved around a bit. And if we zoom into the board ID, what we can see is this board is known as 560 and the diagram is 559, and I'll show why that's important in a minute. Now, there was a transcript on a website. I came across it a couple of weeks ago, but I haven't been able to find it again. But basically, there was a reunion of a number of the engineers who designed the original DeskPro 386. And as part of the transcript, they did say that when they published the circuit diagrams, they did miss some bits out. And so with that in mind, I did actually want to go through and make sure that the internal design document that I had was complete and there weren't any chips missing. And so what I did is, comparing against this particular photograph here, there is a diagram in the PDF document that I'll be showing you in a few minutes. And what I did is I just went through and made sure that every chip is actually referenced. So each of these numbers here is basically the sheet number. So I went through and ticked off all of the chips on all of the schematics and actually correlated them with this. And what I'm happy to say is that they all largely tie up. There is one slight difference in that this says this is a 7407, and in fact it was replaced with a slightly more recent part, an ALS 1035, which is very similar. It's basically a hex buffer with open collector output. But that was the only discrepancy I really found in this process. So what we can be sure is the diagrams we're working from do accurately reflect this version of the board from December 1986. Now, I also mentioned in the previous video that this is one of the last PCs where most of the logic is done in TTL and small programmable logic devices. This DeskPro 38620 20 megahertz version from October 1987, you'll see that there's actually some larger chips here. This 82385 is actually a cache controller chip. I think this section here may have had the static memory cache. This is the beginning of large-scale integration devices being used actually on the board to actually replace a lot of the LS logic that we'll be looking at. And you'll see in particular this one here and this one here are something like 100, 130 pin chips. which replace a lot of the other logic. So if we look at this board, you can see here that this chip here and this chip here is some of that sort of very large scale integration logic, and you can see this is where the cache controller goes. And in fact, when we look down here, you can see that the oscillator driving the 20 megahertz one is in fact a 40 megahertz crystal. So generally the CPU clock 2 signal is normally twice the frequency of the actual processor clock. And then just to show where this ended up, about 10 years later, this is a DeskPro 386N. So this was a 386SX. So this had a 16-bit external bus. From 1996, I believe this also has a VGA controller on it. I think probably one of these chips here is the VGA controller. These two clock frequencies here are in fact the VGA frequencies. If we go in here, you'll see down here we've got 25.175 megahertz and 28.3 megahertz. So these are the VGA frequencies needed for the 720 dot text mode and for the 640 by 480 graphics modes. And you can see here that the memory has now been replaced by DIMMs or SIMMs, and there is still, I think, the slot there to plug in the old memory cards and things, but things have moved on. But you can see here that there's just no way really we could consider building this type of PC on breadboards, because the number of chips we'd have to build breadboard adapters for would be ridiculous, and we may as well just build a PCB. So really the DeskPro 386-16 was really the last practical PC that we really could build on breadboards. Bearing in mind the transcript from the reunion of the DeskPro team saying that they missed out certain bits of the diagrams in the technical guide, I thought I'd go through and just do a quick comparison. So what I've got here is the schematic diagrams from the original technical guide from September 1986. And this one is the schematic diagrams coming from the internal design document. And you'll note here that the board that this references is board 403, which was the first board that we looked at, which was September 1986. And the second board is 560, which is in fact the board that was a second one, which was the December one. And you can see that also that the diagram referenced on there was 559. And if we just zoom in here, you'll see that in fact the diagram on this drawing number is in fact 559. It looks like they took out all of that internal drawing number information out of the images that they actually put into the original DeskPro documentation. So what I've done here, I'm not going to be going through these in great detail, but again, if you want to skip over this and go to the next part, and if you go to the chapters at the bottom, you can actually get a list of the chapters and skip over these bits. But I'm going to be going over it fairly quickly. So there are about 11 or 12 pages of schematics to do. So to start with the CPU and clock board, then the biggest change really is that in the more recent one, then there's a separate page where the Matco processors go. So in the first version, it only supported the 287, that's the PCAT 286 Matco processor, because the 387 one hadn't been released by Intel at that point in time. And also down here, if we have a look, you can see that this is in fact the 82384 clock controller chip. So this was the Intel provided chip for doing the clock signals and also for providing the reset handling. Now in fact, COMPAQ had actually replaced that chip. It was replaced basically just by one flip-flop for the reset logic to coordinate that with the clock signal, and also a couple of CMOS buffer chips which actually provided the voltage requirements for the clock 2 input in here. So the clock 2 input on here required CMOS level of voltages, not the normal TTL ones. And so they did this rather than using a special Intel chip like this one. This was replaced literally by these two chips. So that's something which certainly is interesting and avoids having to go out and buy expensive second-hand chips for this. Now I should also say, if we look at the documents themselves, so this is the original DeskPro 386 reference, which I'll include the links below. And if we actually go to the page where the schematics start, and if we just zoom in here, you'll see that this actually says PCB part number 403. So we know that this particular version of the diagrams here refers to that original PCB that I showed you. And then if we go to, this is the internal design document. Now this one actually is the references back to the original board. This is just an overview diagram. But this was the diagram I showed you where I went through cross-referencing everything on the schematics. Then when we get down to this one here, we can see this is 559, and it also references PCB 560. So you can be sure that these are the correct diagrams that we're actually looking at. So on the next one, on SIS3, there are a few differences. So you'll notice that some of the labels and things, the timing, for example, rather than using certain signals, they've been replaced by others, and also where the output of certain things. So for example, you'll see over here that the interrupt acknowledge signal is now coming out of this chip over here, whereas previously interrupt acknowledge isn't in here. So they obviously cleaned up the board somewhat and moved certain signals around. This is one of the ones where this particular signal over here, if we look over here, you can see that there's a trace going from here to the memory read there. And we can also see that this one up here is just going from here straight into the output enable. But on this one, you can see that this trace is actually missing. So this is one of the few bits I did find that there was a bit missing. So this line here is definitely missing. And this one here, there was an additional flip-flop in here. And again, some differences. The int acknowledge was actually coming out of this chip in the earlier version. So there are some differences. This was one of the few mistakes that I actually found, or whether it's deliberate that they've taken that out. And then there are other areas where these two chips are replaced with this one here. There's an area of the logic relating to the speed control. So this was manually changed on this particular version of the document. So when I've been doing the KiCad diagrams for this, then I've actually implemented this, and you'll see that over here that there are differences, that this was the original diagram and this has been the modified version of it. There's an additional signal at the top there. And just some of the labels and things were relabeled between the two versions. And you'll see here on this particular one, there are some differences in the labels, but in fact, the logic here was actually moved down here and the logic here was moved up here. Now, the bus state machine is the thing that really replaces the bus controller on the earlier generation PCs. And on the DeskPro, it's really complicated. The rules around here are making my head hurt. And this is going to take a while to really get to the bottom of exactly how it all works. But you'll see that there are some interesting differences here. This is one of the clock outputs. So the bus clock here, I think, is about an 8 megahertz clock. And you'll see here it has a 30 ohm resistor to try and clean up the output signal, whereas on this one it has a ferrite bead. So again, there have been changes in the way how certain of the high frequency signals have been handled, and again we've got sort of slight differences in that the T01 there has been replaced by the T10, the slightly different bus timing clocks on here. Now this is an interesting one in that pretty much the ROM board was the same, however they've actually put an additional program or logic device in here. And this was basically put in over the top of the keyboard controller, and it was designed to enable the low A20 line to actually be intercepted. Apparently the reason is that the 8042 controller took too long to actually implement the changes to this particular output line, and so this PLD was developed to speed it up. Now, we don't really need to worry about that too much for the Breadboard 386 PC, because the VIA82 C42 is actually implemented in hardware, and I suspect it will be much faster than the original 8042 microcontroller. Then we've got the ISA bus connectors. Now again, there was just one small difference here. You'll notice that the clock signal here doesn't have anything on it, whereas the bus clock here again has some additional components here, and I suspect these again to stop reflections and things to improve the signal quality across here. And these type of changes are interesting in that the tutorial series I did previously, for which there will be a playlist in the description below, in the buffers section we did actually look at how we would need to put additional pull-up resistors and additional components to actually sort out problems to do with running high-frequency signals over bus rails. So the other important part of the DeskPro 386 was it had a separate 32-bit memory board, and this section here is all about how the memory board plugs into the processor board. And again, there were a few minor changes. So the signals used for certain of these, triggering a certain of these signals was modified. So I thought I'd just show you the KiCad diagram that I've been working on. It's not complete, it's still work in progress. What I've tried to do is to lay it out using the layouts of the existing sheets, and you'll see that the sheet numbers for the DeskPro is on the bottom right hand corner here. I'm using some of these global labels for where we've got the edge of board sort of connections. In some cases I may very well to join these up between the various boards, because I've tried to make sure that these are actually located close to where it makes sense. And in some cases the bus rails are actually running between all the boards. But I'm still halfway through doing this. I need to add all the 32-bit memory boards up here. But I will again publish this on GitHub, so if anyone wants to have a look at it, improve it, fix it, there will be the odd mistake here and there, but what I've tried to do is to keep the chip layout as close to the COMPAQ originals. And you'll see here this monster here is the 132-pin 386 processor, and this is the top-down view of the processor. You can see that it's actually got 14 pins along each side, A to P, 1 to 14, and all the labels here actually refer to those pins. So again, there's going to be a lot of cross-checking of things to make sure I don't wire up things incorrectly, and in particular when I'm wiring up the breadboard connector for this chip, making sure I don't actually fry it is going to be important. So in summary then, our breadboard 386 PC, we're going to be trying to run MS-DOS, Windows 3, 3.1, 95, and probably Linux Slackware as well, probably one of the early releases. I'm going to be trying it with the CGA graphics controller that I developed in the previous series. I will also try and get the VGA ISA bus controller working. Hopefully that will work with this version. I couldn't quite get it working reliably with the 8088 breadboard PC. So we're taking these bits over from the PC and PCXT. We're obviously adding the bits from the PC80. Some of these we've already done, so the fast serial port and the dual interrupt controllers are already done, but the 16-bit DMA, the 16-bit ISA bus, and the A20 gate handling. So this is so that old programs that didn't know about more than 1 megabyte of memory would still work properly. The PS2 stuff is still pretty much the same as we did in the previous series, but then with the DeskPro 386 we're going to be adding a 16-bit IDE controller, so I'm going to change the disk controller design to be more like the original DeskPro. I'm going to be adding 2 megabytes of RAM first, but then I'll add an extra 8 megabytes so we can actually run Windows 95 and Linux. And we'll also be looking at shadowing the BIOS and VGA ROM. So I'm going to finish the video there. The first one was a bit long, so apologies for that, but if you use the chapters you can skip through a lot of the schematic review if you're not into the technical detail. In the next video I'm going to be looking at building the PGA 132 386 to breadboard adapter. So I need to get a certain amount of this diagram completed to actually know what I'm going to need to plug it into before I can do that. So if you don't want to miss out on future videos in the series, then please hit subscribe if you haven't already. Please feel free to put comments below, and I do try and respond to them within about 24 hours. And if you found the video interesting, please hit like, it just helps to make it available to more people on YouTube. Thanks for watching.